Let's take a look at an example to see how the confidence interval equations work. In a random sample of 500 adults, 300 stated that they believed in love at first sight. A question like this would be asked if we wanted to determine the true population proportion of people that believed in love at first sight. Our end goal is to come up with an interval that represents a reasonable range of estimates for this value of the parameter. In order to do this, we're going to follow this four-step process. And the first step is going to be to create the sample proportion of people that believe in love at first sight. Recall that the sample proportion, p hat, is equal to the number of people that say yes, or in this case 300, divided by the total number of people that we asked, or 500. Calculating this gives us the value of 0.6. Next, we want to calculate the standard error. We can find the standard error by taking the square root of p hat times q hat over n. P hat we just calculated to be 0.6. Q hat is going to be 1 minus p hat, or 1 minus 0.6, which is 0.4. And then we divide this by the total number of people that we asked, which was 500. Plugging this all into your calculator, you should end up getting an answer of 0.0219. Next, we want to make sure that the conditions for inference are met so that we can actually go through and calculate this confidence interval. We need to make sure that we've got a random sample, which we do. And we also need to make sure that the number of yeses and the number of nos are both greater than or equal to 10. 300 people said yes, they believed in love at first sight out of 500. That means that there were 200 people that said no, that they didn't. We have both of those conditions met, we can create our confidence interval. Our equation says that we need to take p hat plus or minus z star times the standard error. We already found p hat in part 1, that was 0.6. The z star value we calculated on the previous page using our applet was 1.645 for a 90% confidence interval. And that gets multiplied by our standard error, which we just found to be 0.0219. I like to calculate this piece over here first. We call that the margin of error. That's going to end up giving us 0.6 plus or minus 0.036. And then this will end up giving us an interval of 0.564 to 0.636. When we write our interval, we generally put the smaller number first and the larger number second. It's because that's how we talk when we speak in English.